Jupiter's Great Red Spot seems to be changing. Certainly the largest, reddest, and spottiest storm in the solar system is also the most famous, but the question of why it keeps growing remains unanswered. To add to the growing body of research on Jupiter's Great Red Spot, a new study has been published in the journal Geophysical Research Letters. It demonstrates that the GRS is losing its cigar shape and gaining a more circular one as the winds near its periphery pick up speed. Does this spell the end for the Great Red Spot? Actually, no. Unprecedented results. However, there was no consensus on how to explain the findings of this current research, and several of the experts involved have expressed astonishment at the results. Astronomer and co-author from UC Berkeley Mike Wong commented, "No one had predicted what was truly going on. When we discovered what we had done, it was difficult to explain." The fate of the Great Red Spot is unknown, and nobody knows if it keeps growing or if it's shrinking. No spacecraft dispatched to Jupiter has been able to definitively answer the issue. And even with the greatest telescopes available, we cannot see deep enough into the storm to determine its origin. We may not know everything about the storm, but we may attempt to piece together what we do know from its history and present to predict its future. The Great Red Spot. What is it? Located in Jupiter's southern hemisphere is a system of high pressure known as the Great Red Spot. This powerful anticyclone rotates counterclockwise around its own core. The Great Red Spot is frequently called a pancake due to its form and structure. A storm that travels at 270 to 425 miles per hour has a nice name, but it's a little deceiving. The Great Red Spot has been studied by scientists for close to 150 years, yet its origin and formation remain mysteries. It may be far older than what the oldest records indicate. Despite its reputation for viciousness, it even consumes lesser Jovian storms. The spot's bite size may vary. According to Amy Simon, a planetary scientist at NASA Goddard and co-author of the research, you could fit roughly 3 Earths across the Great Red Spot during the Voyager period. It used to be much larger than Earth, but it has been progressively decreasing and is currently barely bigger than our planet. It's important to remember that the Great Red Spot travels about like any other storm. Its constituent parts are constantly shifting, sometimes in subtle ways. Some of these shifts were discussed in Simon and Wong's most recent publication. They discover that the storm is narrowing in height rather than width as it weakens. Nobody knows whether or how long the Great Red Spot will continue on its current course. Unknown elements. Exactly where did that hue come from? Though we have some hypotheses, it is difficult to discern the truth on any level. We don't know what compounds make it red, Simon added. However, we believe that photochemical compounds such as smog are implicated since the area is blanketed in thick haze or clouds. The Great Red Spot's coloration has both positive and negative connotations. Some experts blame the crimson hue on chemicals deep inside the storm's clouds. Others, however, have suggested that the sun's breakdown of compounds in the storm's upper atmosphere is responsible for the rusty hue. The remainder of the Great Red Spot wouldn't be particularly red if this were the case. It's possible that the sunburn on top will be noticeable. What is happening to the winds around the Great Red Spot? Pieces of the Great Red Spot were seen flaking off the main body of the storm in 2019, as seen by amateur astronomers. Some researchers began to wonder whether the Great Red Spot was really dissolving as a result of this phenomenon. Data from the Hubble telescope had previously been examined by Simon Wong and the rest of his team from 2009 through 2020. The researchers compared the velocity fields of the Great Red Spot before and after the 2019 flaking. And after extensive statistical testing, they found that the storm's outermost lane, or high-speed ring, had experienced an increase in winds of about 8%. Conversely, winds were much slower outside the storm's core. When we initially saw the GRS was shrinking, we assumed the winds would increase to maintain angular momentum, like a figure skater drawing in her arm to slow down. but we didn't quantify that. While it is clear that the GRS is expanding and spinning more quickly, it is still unclear whether or not these changes are temporary or represent a permanent transformation of the GRS. Keep in mind that despite their unexpectedness, these shifts are rather minor. According to Wang, it was only through analyzing data over a long period of time that the team was able to detect the fluctuations in wind velocity. If you did 2 separate observations 2 years apart, you wouldn't notice it, Wang added. Unless you go back 11 years, you wouldn't be able to appreciate the transformation. Mysterious winds. How come the winds around the Great Red Spot pick up speed and then die down? With the resources at our disposal, a straightforward explanation of this phenomenon seems implausible. Hubble's limited field of view prevents us from learning anything about the Great Red Spot's inner workings because of the storm's cloud cover. We could learn more if we could measure the depth of the GRS, but even the best spacecraft estimations are murky. Since Juno's 2017 investigation, we have learned that the spot is 50 to 100 times deeper than Earth's seas, but the storm's exact boundary remain unknown. The red patch on Jupiter has had a difficult go of it recently. In the last 10 years, winds near the coast have increased in intensity according to a new study. Along with its size reduction of roughly 1,900 kilometers a year, the location is also altering its appearance. As time goes on, the location shifts. It's getting less cigar-shaped and more circular. If that pattern continues, by 2035 or 2039, it might be totally round. The red spot is generally just this round spot, but scientists saw that it was not completely round. It became apparent that parts of the photographs were breaking off as they worked on them. Nothing like that has ever happened before. Is Jupiter changing? Tell us in the comments, leave a like, and subscribe for more videos like this.